And welcome everybody to the Daily Space Weather. I'm your host, Dan, aka smAsho. Today we're starting things out looking at the last week of solar activity in terms of colorized magnetogram. As solar activity has dropped a bit, and we'll cover a whole bunch more views coming up. 10.7 centimeter radio flux is at 100. Here's a 1-year chart of that. Let's refresh. There you go. And there's the radio flux chart on the Space Weather Enthusiast dashboard going back to the peak of cycle 24, which peaked around 170 solar flux units. And for you new viewers, thanks for tuning in. The radio flux in the 10.7 centimeter variety is extremely proportional to the sunspot number. We've got some great Helio viewer movies for you. Stay tuned to the end of the video for those. Also, we will be doing a live stream following the premiere of this video, so make sure you come back to the channel, youtube.com/smAsho. It'll be another YouTube exclusive live stream. We'll be talking about news and other things like that. It'll also be a viewer chat session, so show up, leave questions, comments, etc. We'll talk all about it on today's smAshlights live stream YouTube exclusive. Let's talk cosmology for a quick moment here. In today's Daily Space Weather video cosmology segment, we're not going to throw any dice. Here's the state of affairs for Cygnus X3. Now, why are we talking about Cygnus X3? Because it's one of the only known cosmic ray point sources. And we've been monitoring this thing closely as it is a high-mass X-ray binary. And without getting all into the details of what this object is and what it means, we're looking at X-ray emissions here at the Neil Gehrels Swift Burst Alert Telescope, the BAT X-ray Observatory. You can see here's the past 30 days of activity, and you can see it's right in its sweet spot of its range here, right around the baseline. Cygnus X3 is right now. We watched it at the bottom, we watched it at the top, and we're always interested in this particular object. That's the current state of affairs for Cygnus X3. It is the most luminous object visible in the Milky Way galaxy from the position of us, the solar system. It's known as the star Deneb, the tail of the swan in the constellation Cygnus. Next, I would invite our viewers to check out smAshomash.com. You can find all of our social media sites there, as well as links to our forum at smAshomash.com/forum, as well as our stores. Today's featured product is the Mansa shirt. Yes, we invite you to make America not suck again, since it's up to you, not the government. And currently I'm wearing the purple one. Right now, you can see it right here. There you go. Mansa, make America not suck again. It's also got a link to our website on there. It's up to you, not the government. Don't forget to enter the promo code smAsho on all orders. At checkout, you'll receive a 10% discount through Christmas. Again, you can link to all of that at smAshomash.com. Next, we'll have a look at the real-time solar wind, and we've brought up a 3-day chart here instead of a 1-day chart to show you this ramp up. And we're at a more normal level of solar wind here. Current solar wind speed around 364 kilometers per second. Solar wind density at 6.5 protons per cubic centimeter. Phi angle's been a little bit shifty. No surprise there. There is a coronal hole wind stream on the way. So look for an uptick, a further uptick in the solar wind density, followed by a downtick in the solar wind density and an uptick in the solar wind speed, the signature of a coronal hole wind stream. KP index currently at 1, and we saw extended periods of KP 0 here. That's a 3-day chart of the measurement of overall global geomagnetism. Let's look at cosmic rays. Here's the Apatity neutron monitor, and you can see a downtick here over the past 30 days at Apatity, as well as at Barentsburg. Next, we'll go farther south and take a look at Athens, Greece. And there's the Athens neutron monitor. looking quite similar there to both Apatity and Barentsburg, an indication that the data is legit. And for that, we thank you. Next, even farther south, the Mexico City Cosmic Ray Observatory. And there you can see a similar chart at Mexico City as well. A slight downtick over the past 30 days. Lastly, we'll look at Oulu, Finland, and DOMC Antarctica. And there's the Oulu chart, another chart corroborating legit data about cosmic ray flux. A bit of a downtick over the past 30 days at Oulu. Let's check DOMC Antarctica. And a similar shape to the chart there as well, although a slightly flatter 30 days. Next, we'll take a look at the magnetosphere. Here's the past 4 hours. And we see a more normal visualization here of the magnetosphere. We'll let that play through as it refreshed for your convenience or your inconvenience, depending on how you look at it. Pretty normal there. Next, we'll look at ground magnetic perturbations. And we see some perturbations here. These must be chiefly magnetic. We see significant magnetic pulses here coming out of the Pacific Ocean, as well as over Antarctica, and both the Siberian and Canadian North Poles. In fact, I'll let it play through a second time here. As we've shortened today's video a little bit, it is a recorded video as opposed to a live stream. And since it refreshed, we'll let that play through too, for your convenience or inconvenience, depending on how you look at it. Again, this is 4 hours of data. It's all about the Space Weather Modeling Framework, University of Michigan Geospace Model V1.5. The proton flux has subsided here, and we're back to background levels of proton flux. Give it about another 36 hours before your earthquake watch expires, as we are continuing to see a drought of 7, 8, and 9 magnitude quakes. Here's a 3-day chart of the X-ray flux. And don't get your protons and your photons mixed up. Coronal mass ejections are primarily protons, and solar flares are primarily photons. So there you can see no significant flaring over the past, I'll say 12 hours. But a couple of 3 C-class flares actually occurred yesterday. And we actually do plan to make another smAsho.org Present the Sun video. Perhaps that'll come out today. No promises. And here's a star chart for you spaced out viewers. I like to face mine to the south and draw in the ecliptic here at in-the-sky.org. And the sun will rise into Libra today, chasing Venus, my favorite planet, the third brightest object in the sky. And here's what's going on in the solar system today on December 6th. There's where things will be in 1 week, approaching another new moon. And let's go to Lagrange point 5 to see if we see any coronal mass ejections facing the Earth. Indeed, we don't, but we do see Venus out there. So a great visualization of where Lagrange point 5 is located. Obviously, it must be right here, as we have nearly a straight line between stereo A, the Sun, and Venus. So there's the view from stereo A's Space Weather Beacon Coronagraph 2. And I would note one thing here. There is a significant possibility for coronal mass ejections once again, as we see these 3 or 4 plasma filaments protruding in the Earth-facing zone. So solar flare watch is still in effect, and the likelihood of large solar flares and coronal mass ejections actually increases as the sunspot currently facing the Earth moves into a more westerly position. GOES magnetometer has shown some pretty spiky readings here around midnight local time for the satellite. And for you new viewers, these N's and M's, those mean local time for the satellite, the GOES 16 on the opposite side of the planet from the sun where it says M. And we do see these magnetic perturbations here. That's pure magnetism, not solar proton-induced magnetism. Here's a view of the heliosphere. The Earth is solidly in the South Pole current sheet shown here in red. Don't be surprised to see that suddenly change, as the magnetic environment suddenly can. That data 1 hour and 30 minutes old. It's the top view ecliptic plane field plot. Which, by the way, is one of the most important features for solar forecasting. Next, looking at the line of sight coronal hole field plot. And the coronal hole, which will be supplying some enhanced solar wind in the next 2 days, is actually a south polarity coronal hole, shown in red. It's up north of the equator as the solar cycle advances. Here's a line of sight field plot, which shows you the B field in blue like the last slide, as well as the solar Z fields, the poloidal fields coming out of the poles of the sun in green and red, as well as the solar magnetogram. And last but not least, we'll look at the solar coronal magnetic field plot, a field plot of the potential field surface source lines of just the solar atmosphere, which is quite chaotic. And it does give us some insight and some forecasting ability. I won't get into it in depth today, as it is a daily space weather video, not some sort of astrophysics and cosmology segment. Next, we'll look at electrons, as they are very important in terms of space weather. This is an illustration of the Van Allen belts. You can see the inner and outer Van Allen belts, as well as the locations of various different satellites, such as the SDO, GPS satellites, and the Van Allen probes. We don't see any charging hazards right now. NOAA is forecasting a big uptick. There's the 1-year chart of the electron flux. NOAA is forecasting a big uptick, and I'll have to disagree with this one. This is going to be down here. So they've forecasted a downtick a little bit prematurely. Maybe they expected the coronal hole wind stream to arrive earlier than I did. I'll have to disagree with that massive uptick in the electron flux. And here's a 3-day chart of the electron flux as measured by the GO-16, which measures it at the F2 ionosphere layer. Here's a visualization of the electron content forecast, and we see some anomalous electron densities over both North America and Antarctica. You can see there at the end of the run. I'll let that run through a second time. And that's the entire air column, all the way from the thermosphere down to your GPS handset, potentially. And here's just another illustration of the different layers of the atmosphere, from the troposphere, where all your weather occurs, up to the upper thermosphere. Here's a map of one slice of that. It's the ionosphere F layer. Not looking particularly special today. Nothing to write home about. There's the latest image coming in at 11 o'clock Universal Time. And we've seen a relaxation of these absorption regions, so we don't see anything showing up on the absorption predictions map. And that is a result of the subsiding of that proton flux that we saw for the past week. Again, the earthquake watch does not end for another, I'll say 48 hours, but 36 to 48 hours. Still a significant possibility of a large quake. Again, the 7, 8, and 9 magnitude drought continues. Earthquake droughts end in large earthquakes. We'll look at it momentarily. First, volcanoes. Let's see what's going on here at volcanodiscovery.com. Klugeskoy is still erupting, still producing a 23,000-foot ash plume. Now Mount Manam in New Guinea on the list. flight level 080, an 8,000-foot plume there, as it explodes, similar to Luatolo, which is relaxing a bit, although still exploding, producing an 8,000-foot plume of ash. Popocatépetl, uptick at Popocatépetl down in Mexico, as it explodes, 28,000-foot ash plume above that caldera. Revenador exploding in Ecuador, 16,000-foot ash plume there, and puff emissions in Sabancaya are a reminder not to attempt to fly in a wingsuit over the caldera. It could be a bad day. Here's the past 24 hours of earthquakes. Looks like the largest of the past 24 may have been this 5.3 in Turkey. Here's an extremely shallow quake at Hawaii. Let's check out the location of that. Do you think it's under Mauna Loa? I'll be finding out perhaps at the same time you do. It's a pre-recorded video, not a live stream. And indeed, that one is under Mauna Loa. That quake happening at a depth of negative 1.1 kilometers, 1,100 meters above sea level. So some magmatic activity under Mauna Loa. A deep quake strikes Chile at a 4.2 magnitude. Here's a deep quake in the Tyrrhenian Sea, which I've never heard of. A 4.2 magnitude at 452 kilometers depth. Looks like it's adjacent to the Mediterranean, near Naples. So there you go, a very deep quake located off the west coast of Italy. And back to the list we go. Another small deep quake strikes south of Alaska in the shallow Aleutian Islands. And another very shallow quake strikes near Pahala, Hawaii. And that one located also under Mauna Loa at a depth of 900 meters above sea level. Earthquake risk does not expire for at least 36 hours, folks. Next, looking at windy.com's pressure maps. There's where pressure cells are now, an extremely strong low pressure system there over the North Pacific, as well as some heavy snow striking Maine. We'll advance this into tomorrow. There's where we expect pressure to be according to the GFS forecast. Tomorrow, a low pressure off of North Carolina as well. High pressure over the northern Rockies, as the low over Maine spreads out and heads toward Iceland. It's barely 2 weeks until the solstice. Where will you be on Monday, December 21st at 5:02 Eastern Standard Time? I'll be streaming live. Perhaps we'll be the first channel on YouTube with our live stream exclusive to wish you a happy solstice 2020. Let's take a look at the jet streams. There's where jet streams are now in the western world. And we've got an anticyclone there over the northern Rockies. And for you new viewers and meteorology noobs, an anticyclone is a clockwise rotation typically associated with high pressure in the northern hemisphere, or indeed a counterclockwise rotation in the southern hemisphere. Anticyclones, a serious input to meteorological phenomena. And here is the eastern world's jet stream scenario. We're looking at the 250 hectopascal winds at nullschool.net. Next, looking at lightningmaps.org to see quite a relaxation here of lightning, although some around Italy. Here's a NASA GOES lightning mapper, and we do see some lightning in the past 5 hours here in the Gulf of Mexico, as well as the North Atlantic. Next, how about a U.S. Doppler radar map? And you can see the entire state of Maine pretty much coated with snow. And some snow showers falling on Pennsylvania and Illinois as well. Let's look at some more meteorology stuff. How about the NASA GOES interactive weather satellite? And here's what's going on in the cloud layer as we have recorded this video before it's light. Look at all the low clouds once again over the Atlantic. Those are low clouds, folks. They're back. And here's what's going on in the water vapor layer. A great view of that low pressure. I don't know why the heck it is playing so slowly. Give it a minute. There we go. Great view of that low pressure, which is over eastern Maine there, it looks like. And all that more moist air is surrounded by dry massive air. And we'll do a zoom in for all of our New England viewers. Shout out to Mr. Keebler. And there you go. There's a close-up of New England and the mid-Atlantic states. That counterclockwise rotating low pressure system there. Great view of that. And it is indeed stagnating here. Time for bonus features, starting with the colorized magnetogram of the local yellow dwarf. That sunspot has degraded since yesterday. I would also note this active region over here. Let's take a look at the umbra. There's the umbra. And the sunspot number is dropping here, so we're going to see a reduction in sunspot number here. And indeed, that is a sunspot, so that's a beta class. And again, as this sunspot rotates out of the Earth-facing zone, the likelihood of solar flares actually goes up, and there's still significant possibility for sunspot 2786 to provide solar flares and coronal mass ejections detectable at Earth. And last but not least, we've got our HelioViewer movies here, starting with the 304 angstroms full disk view. Plasma filaments in the northwest, as well as the southwest. Great view of that. And here's the 171 angstroms full disk view. It's 1 day of activity. And we'll definitely have to make another video today in addition to the live stream, which will be premiering right after the premiere of this. And we'll include about a week of solar activity there. Part of the reason why we showed you the week-long colorized magnetogram at the beginning. Next, we'll do some close-ups. Here's the northern region in 171 angstroms. Here's 304 angstroms. And a small prominence there, or two, from the North Polar region. Here's me vanishing. Here's the South Polar region. In ionized helium UV emission spectra. By the way, please press like and subscribe if you enjoy the content on YouTube. Thanks to our new subscribers. Thanks everybody leaving comments. Please share on your social media. Visit our links. Help support the channel. Consider becoming a patron. The true source of funding for the content, patreon.com/smAsho. Thanks to our patrons. We've got one more bonus feature, so don't go anywhere. It's the Southern Polar region in 171 angstroms. My favorite wavelength. Thanks again, patrons. There you have it. It's about time to close this thing out. Thanks for viewing, everybody. Remember to stare at the sun and attempt to understand the physics. Since astrophysics and cosmology are being rewritten before your very eyes. We'll see you soon with our live stream. Welcome to the Neo-Renaissance, and may that solar wind be at your back.